Hello everyone, my name is Lorena Cardoso and I am petroleum engineering master's student at Unicamp. My research is about the influence of production system integration on polymer fluiding and a heavy oil reservoir. So, polymer fluiding is an EOR, enhanced oil recovery technique, in which polymer solutions are injected into the porous medium, often alternating between polymer slug injection and water injection. Injecting a more viscous fluid reduces the mobility ratio, resulting in a more uniform flow distribution in reservoir, which increases the final oil recovery. Okay. Uh, Artificial methods offer additional energy to elevate the fluids in well. In this work, we will focus on the electrical submersible pump, or ESP, that are a lifting system that consists of a pump style inside the producer well. This configuration allows the pump to be positioned directly in the production zone, eliminating the need for complex surface equipment. The producer fluid is propelled by the action of the pump, which generates kinetic energy by accelerating the fluid, providing the necessary pressure to overcome flow resistance and bring it to the surface. Okay. Um, Reservoir production is affected by well characteristics, formation damage, type of completion, artificial lift method, and production systems. And non-integrated simulations means not consider this well and to face conditions leading to inaccurate results. One of the integration strategies is the decoupled integration approach, where a production simulator is used to obtain boundary conditions at the wells for different separation scenarios, and these conditions are implemented in the reservoir simulator. Despite studies on polymer fluiding have been widely reported in the literature, but integration with the production system is often neglected, resulting in production losses, increased costs, or inaccurate production forecasts. In this work, we will also propose an alternative strategy that we will call revised BHP approach for estimating production for an integrated scenario using a non-integrated simulation. This reduces the simulation time and complexity once just one software is used. Okay, about the methodology for reservoir and production system. For the simulations, we used a reservoir model called EPIC001 that was constructed to represent a portion of a real offshore sandstone heavy oil field with an oil gravity of 13 degrees API. The reservoir has initial pressure of 223 bars, temperature of 82 degrees Celsius, and water depth of 120 meters. This case study includes 7 wells comprising 4 producers equipped with ESP and 3 injectors. Okay. To integrate reservoir with production system, we use the coupled integration approach using vertical flow performance tables generated in a production software for different water cuts and reservoir flow conditions. We simulated 3 scenarios for non-integrated integrated and using the revisited BAP approach. The first was 100% of simulation time with water fluid, and the other with 75% of simulation time with polymer fluid at concentrations of 0.5 kilograms per cubic meters and 2.49 kilograms per cubic meters. The alternative approach to integration emerged with the idea of adding a pressure drop in production system that represents the effect of production system in the wells without the need to use an integrated approach. This would reduce computational time and eliminate the need for using two software programs, for example. We evaluated different BAPs to be set in the non-integrated case to find the best conditions that fits with the integrated case. For this, we conducted sensitivity analysis by varying the minimal BAPs in wells from 125 to 190 bars. After completing these steps in the methodology, the goal was to compare the non-integrated case versus the integrated case versus alternative approach. Okay. About the results here, influence of integration. The first graph shows a comparison of the total oil production between the case considering water flooding without integration and the integrated case. It's observed that the implementation of the production system, red curve, resulted in lower production, causing a reduction of approximately 23%. This highlights the significant impact of pressure drop on the final oil production and underscores the importance of considering the production system during reservoir simulation. Below is the same comparison for the polymer fluid casing, considering a concentration of 2.49 kilograms per cubic meters. It can be observed that integration with the production system reduced the oil production by about 42%. Note that in the case of polymer flooding, the impact on production was much greater as a consequence of the increased fluid viscosity, leading to higher pressure drop. This other graph represents the difference in final oil production for each polymer concentration between the non-integrated and integrated cases. It's evident that the higher the polymer concentration, the greater the difference in final oil production. Okay. Now about the alternative BAP approach. This first graph shows sensitivity analysis by varying the BAPs for the polymer fluid casing, considering a concentration of 0.5 kilograms per cubic meters. In this case, the AP that led to the production closest to the integrated case was 182.5 bars. Below, the left graph shows oil production as a function of polymer concentration for the non-integrated cases in blue and for the integrated cases in red. with the revisited BHP approach in gray. Okay. It can be observed that the non-integrated case produces significantly more oil than the integrated case. Another important point is that in terms of production, the graph obtained with the revisited BHP was quite similar to the integrated case, indicating that this methodology is consistent. The result was that to arrive at the revisited BHP, we add the 60 bars to the minimal BHP of the base case with a variation of 2.5 bars more or less. The interpretation of this result is that polymer integration doesn't have a significant effect on the variation of the revisited BHP, meaning it does not depend on either the polymer concentration or have much influence on water cut. How many conclusions we can draw that is considering the integration considerably impact of production forecast. Non-consider the integration could lead to inaccurate production strategies decisions, and the revisited BHP approach could be an alternative to estimate the integrated scenarios. Thank you for attention.